All right, welcome to our lesson on inverses and compositions of square roots. So we've done inverses and composition of functions before, so a lot of these will be the same steps as we've used. We always want to substitute y for f of x. Then we want to switch x and y, and then we solve for y. And finally, we replace y with f inverse of x. So hopefully that kind of jogs your memory a little bit. Remember, to get rid of a square root, you must square both sides. To get rid of something squared, you must take the square root of both sides. So, and it says give our answer including domain and range. So for this first one, f of x equals x squared. So we change it to y equals x squared. Then we switch x and y. So x equals y squared. And now we want to solve. So to get rid of the squared, we take the square root of both sides. And that will give us y equals the square root of x. And then the final step is f inverse of x equals the square root of x. And so then we know the domain, that's the x values, is x greater than or equal to 0 because we didn't shift at all. And the range is y greater than or equal to 0. So that is what the parent function is for a square root. Now, if we go to one where we have something inside a square root, so we have f of x equals the square root of 2x minus 3. So that's y equals the square root of 2x minus 3. Switch x and y, so x equals the square root of 2y minus 3. And now we need to square both sides. So that's going to give us x squared equals 2y minus 3. So then I just solve for y. I'm going to add 3 to both sides. So I'm going to have x squared plus 3 equals 2y. When I divide by 2, I end up with x squared plus 3 divided by 2 equals y, which in this case is now f inverse of x. Now, if you remember, with quadratics, that's x squareds, the domain is always all real numbers. And the range, it's how much we shifted up. So in this case, the k value here is 3 over 2. So we shifted up 3 over 2. It opens up. So our range is y greater than or equal to 3 over 2. So those are our first two. One was x squared, one was a square root. Let's look at the next two. So we've already done x squared. Now we're going to do x squared plus 1. So let's see what the difference is here. So once again, we're going to set y equal to x squared plus 1. We're going to switch x and y. So x equals y squared plus 1. And now we're going to solve. So we have to get the y squared by itself. X minus 1 equals y squared. So now we need to take the square root of both sides. When we do that, we're left with the square root of x minus 1 equals y. That is our f inverse of x. That's our inverse function. So if we look, the square root of x minus 1, we know that x is lie, so that means we shifted 1 to the right. So our domain is going to shift from x equals greater than or equal to 0, like we had in the first one, to x is greater than or equal to 1. Now our range, we don't have a k value, so the range is still y greater than or equal to 0, just like number 1 was. And then we move to number 4, where we start with something with the square root, 1/2 square root of x minus 5. We switch x and y. So x equals 1/2 times the square root of y minus 5. And now we're going to solve. So we have to multiply both sides by 2. So we have 2x equals the square root of y minus 5. To get rid of the square root, remember, we have to square both sides. All right, so now a lot of people will make the mistake saying 2x when it's squared is just 2x squared, but it's actually 4x squared because we have to square the 2. And that's going to equal y minus 5. So then we just add 5 to both sides. 4x squared plus 5 equals y, which is f inverse of x. So now it's another quadratic. So we know the domain is always all reals with the quadratic. But our range, where do we move up? We have a k value of 5. So that means our range is y greater than or equal to 5. So there is the front page of inverses and compositions of square roots, and really quadratics. Now let's flip it to the other side of the page, and we're going to do